All right, welcome everyone. My name is Sumit. I am the lead database platform engineer for Broadcom, and Vinay here, my colleague,
Hi. Hi, everybody.
as a database architect as well. So today we're going to talk mostly about how our experience was to go from Oracle to Postgres. So this was one of the largest Oracle implementation we had with Oracle RAC clustering. We had a I'll go into detail, but just as an overview, it's an Oracle RAC cluster, 3 nodes, and we moved it to Postgres cluster with almost zero downtime. Then we go into a little bit on the challenges. We go into the architecture and then the challenges and migration phases and some of the tools we used, and then some tips and tricks for Postgres. All right, get started. So before we get into the content, so I just wanted to we have some Broadcom software marketing slides. So this slide really just says that we're all connected by Broadcom because Broadcom believes that 99% of internet traffic goes through Broadcom from one of the chips or smartphones or your set-top boxes at your home or whatever that may be. Broadcom is traditionally a chip company, semiconductor company. And recently they went into software. So as you can see, all these acquisitions from for last few years, 2018 was the first software acquisition, which Broadcom did, CA Technologies. And both Vinay and I came from CA acquisition, and then over Symantec in 19, and then AppNeta just recently. So the whole Broadcom software was pretty recent, and just to highlight just on the company formation and how it's evolved over the years. It's a very cost-conscious culture in Broadcom. We're big on standardization, simplification, modernization, while keeping costs always low, having a laser focus on the costs all the time. I won't go into details, but just some data points here: 5 billion revenue. 80% of our workforce is dedicated to R&D and operations, and several thousand patents. Yeah, so we'll skip that. And these are the kinds of software we run. Over these acquisitions. So like on the bottom left here, we have AIOps, DevOps, Clarity, Rally. So some mainframe products as well. And then we have security software. With Symantec acquisition, we gained a lot of security software, and then payment security application. So that's the credit card authentication app. So, all right. Okay. So I will delve into the project and the goals of the project and how design considerations. So. The first and foremost, when we came into Broadcom, our goal was to remove Oracle vendor lock-in. We have been hearing all day long today with all the keynotes with Peter and everyone. Vendor lock-in is obviously not a choice of many customers these days. So definitely that was one of the main goals. Adoption of open source database technologies. So we were a MySQL, Mongo, Oracle, and shop already. We were with Percona already, and now then we decided we'll go from Oracle to Postgres as well. So
why not MySQL or MariaDB, as you have MySQL knowledge?
The main reason was Postgres compatibility with Oracle. So that's what we felt that Postgres. We didn't explore Maria, to be honest. We were mostly running some Postgres in the shop already, and we had some experience with Postgres, so we thought Postgres would be the right choice. Yeah, but yeah, MySQL, Mongo was there, but Maria is a fork of MySQL, correct? Yeah. So yeah.
With lots of features, and biggest one is Oracle compatible.
Okay, cool, good. And that's what we were talking earlier, right? All right. So yeah, we made a decision to go to Postgres because of feature parity, like I mentioned. And then migration to cloud, cost optimization, those were the primary goals. So with our RAC cluster, which we had in Oracle, we were not able to scale horizontally. It was a 3-node rack, and I'll go there in a minute. But to scale that for the future business growth, it was really challenging. Every time we had to we gained some big customer or something of that sort, we had to really spin up new servers and storage and all that good stuff. So yeah, go ahead.
Migration to cloud, if you're cost conscious, if you're going from on-premise to cloud, you basically get a cost factor of 5 more than you paid before. Why did you go to cloud?
So overall, our company strategy was to go to Google. Well, we are using Google Cloud in this case. Broadcom has a good relationship with Google, and we have several. I mean, a lot of good discounts there. So that's
what's the cost compared to if you would have run it on premise?
I think we are saving a lot of money by going to cloud. Yes, with all the costs baked in and all the scalability which we are getting, definitely going to cloud has given us more flexibility. Yeah, so data center comes with a lot of cost as well. I mean, so it wasn't that easy. Then plus so many resources to manage the data center. So yeah.
Plus you're getting all the benefit of a cloud.
But you can run cloud software in your data center. Lots of people do that, and then
yeah, but you're managing by your own, isn't it? There is a lot of standardization is there in a cloud infrastructure. Plus, of course, it's a Postgres, so saving a license from Oracle to Postgres also.
Yeah, but to me, I just wonder, but that's obvious. The migration to cloud, because that's still, in my experience, a huge cost factor.
Sure. Okay. All right. Then on the design side, obviously, since it was a critical application, there was no downtime requirement. Our goal was to make sure there's zero downtime or as little downtime as possible. Like I mentioned earlier, horizontal scalability, IOPS. This is the current IOPS which we were doing back then in Oracle. So that was one of the major considerations around performance. Then maintenance. Maintenance was a big thing in Oracle. We had every month we were doing all kinds of partition maintenance and data archiving and all of that. So it required like a staff of 4 or 5 people just to work through that things, because it was a legacy Oracle DB and lot of dependencies. So that our goal was to have that as minimal as possible going forward. And then these are the numbers we did in both Oracle and Postgres. Actually, we beat Oracle numbers. So 200 transactions per second, which is equating to like 800 database operations per second.
Hardware you did use for Oracle, I assume that was old computers, because nobody has.
Oh, sorry, what?
The computers that you did run Oracle on, how old were they? Because you get a big benefit of running things on faster computers.
Yeah, I mean they were not that old. We refresh hardware as well over last few years. Sorry?
In Oracle license, you pay
by core, exactly. So that was the biggest pain point.
Yeah.
Every time we had to grow, we have to think now millions of dollars of Oracle licensing, because the cores and all. I mean that'll add up. Yeah. And then on top of that, the features you're using, Oracle clustering, the diagnostics pack, the tuning pack, the Golden Gate, and whatnot, right? So all of that will add up over the Oracle licensing. So okay, so that was our this is used to be our Oracle RAC architecture. So we had three Oracle RAC clusters, 3 node each, and running on 3 different sites. Actually, primary and secondary were on the same site, but having separate SAN storage. So there was no single point of failure. And then we had a DR in different data center in 3,000 miles apart, and running again different storage and everything. And we had bidirectional Golden Gate replication going across between all 3. So it was a pretty complex Golden Gate setup, and there were challenges with it, but yeah, it worked. So this setup gave us the flexibility that we can fail over any time. If we had to do major changes here, we could easily point the application to the secondary. So the application was not active, even though database side we were pretty much active. But the application had to be failed over. And this is a monolith application, not containerized, nothing. So that was one of the other goals. I don't know if I covered earlier, but that was another goal, was to modernize the application as well. Go from monolith to microservices architecture and containerize the application. So we went to GKE in Google Kubernetes. So 1 or 2 pain points on the Oracle side wanted to cover here. Well, one was every time there was a huge traffic during holiday season or whatever the event may be, any traffic spikes would cause a lot of wait events on the storage side. Log file sync, if you're familiar with Oracle, log file sync wait event was the big one with heavy volume. And that's practically, that issue, at least in Postgres, has gone away now. So I'll go to the next slide. So how we did the Postgres architecture. Again, this is all in cloud, three compute nodes here. We're running etcd, Percona cluster. Behind the scenes, it runs etcd to do your quorum. And it's like a distributed configuration system, which manages your heartbeat and failover, avoiding the split brain and all of that. I don't know if you want to add anything here on the DCS side, Vinay.
Yeah, so etcd, it's like a key value pair that's checking the heartbeat of each node. So basically, if any node goes down, Percona communicates through the etcd to other nodes to bring back other nodes as a master node. So it's technically providing a together etcd and Percona together provides the HA solution.
Right. So it's I would say, poor man's solution of Golden Gate, a replacement Golden Gate. We had streaming replication, we had a leader, a replica. So these node 2 and node 3 are read-only nodes. Node 1 is read-write. So one of the advantages which we got with this was all our reads and all our reporting type workloads could easily be run here, and we are not bothering our read-write node. So definitely that was a big help. Plus, we broke this humongous Oracle rack cluster where we had several schemas. It's a multi-tenant application, but we run several Oracle schemas. We broke that into individual clusters. So now this is running a set of customers. Another cluster like this is running another set of customers. So we pretty much, we can scale now. If tomorrow I get 100 new customers, I can easily spin one of these new ones. And
as long as you don't need to do cross joins between clusters.
Right, and
right.
There is no licensing cost pretty much. So we can just grow, easily.
But assume that you paid support to somebody just as an insurance.
Yeah, we have support through Percona for Postgres licensing. True. So some costs will be there.
But that's the logical thing. That's the big saving. It's license cost.
Exactly. Yeah. All right. So just going over the migration phases, high level assessment. Right. We need to know what we're dealing with here. You need to know your data. You need to know your data types within Oracle. Don't jump into migrating or using a tool like Aura to PG or whatever. Vinay will cover that in future slide. Don't jump into the migrations unless you really know what you're dealing with, because a lot of changes with data types and a lot of issues we encountered along the way. So definitely scan the code, your application code for Oracle dependencies. I know you were saying earlier before the session we were talking. MariaDB, you didn't have to do that, but or you had the plugin, whatever. Yeah. So definitely scan your code for the dependencies. Then on the application code evaluation, schema migration, there are tons of tools out there on schema migration which will do your DDL migration easily. So that's not a big deal. But like I said, data types. So as is migration from the tool, do not trust on that. You need to review your data and how it converted and all that. Otherwise, it'll mess up on the data types. And we'll go into details on that. Then obviously functional testing goes without saying. You need to make sure your application works end to end. Do a functional testing and migration tools. Performance testing, data validation, all of those go without saying. All right, let's go to the next one. Migration challenges. Okay. So some of the challenges which we had was data volume. This was a 200 terabyte cluster, like I mentioned earlier. So as such, data-wise, I don't see it could be a petabyte. We could still do the same process. Main thing is the challenge is making sure that data gets to the other end and converted and readable and make sure that nothing gets messed up in the data conversion. So the challenge with really is the timing, not really the tools as such. Well, tool choice will matter. Yeah, go ahead. Sorry.
How long did it take to read in the data into Postgres? I assume you have slides for that.
To load
The initial.
So we did in phases. We didn't
Yeah.
do like a big bang. We did in phases, and
Right.
it took several weeks.
Several weeks. Yeah.
Wasn't-
So we'll go over that approach in the next slide.
Okay. Then, like I said, data type mismatch. And we had, like I said, this is an old application. There was lot of this data discoveries we had within Oracle, bad data within Oracle itself, and Vinay will cover that as well. How converting that really messed up, okay, and then application containerization. I mentioned earlier, monolith to microservices, and obviously tight timeline. So the timeline was mostly driven by Oracle license renewal. So we didn't want to pay any extra dime to Oracle. So our goal was to get this done before that. Yeah.
Did you succeed?
Yes, we
Yes.
did.
it is already
Yes,
on
we did.
Postgres.
Okay, with that, I'll turn it over to Vinay to go into a little bit specifics on the points I covered. Vinay?
Yeah. Thank you, Sumit. So I'm just going to go over what are the challenges, or I would rather say lesson learned when we did the Oracle to Postgres migration. To answer your question about the MariaDB, why we didn't go on a Postgres, what to add, what Sumit said, I just want to add a few things. We had a company, some company, I don't want to say the name, but they said that you don't have to convert any Oracle code, you can just migrate everything.
For selected applications.
Yeah, and you don't have to change any of the Oracle code. We have functions, everything which is can work in Postgres as if Oracle. And we had a tons of issue once we started evaluating that software, and then we ditched that software saying that let's go to Postgres. But by that time it was too late. Like everybody was really
Right. So our decision consciously we made that we'll go with native Postgres rather than doing another vendor lock-in with another company.
right.
So-
It's not really when it's open source, and you are using.
Well,
Postgres
in this case it was kind of, but anyway.
Yeah.
we can talk offline on that.
Yeah.
Go ahead.
So one of
Okay, I don't see how MariaDB should be vendor.
Not MariaDB. No,
Not
no, I'm
MariaDB.
not. We're talking
Yeah.
our case.
Yeah.
Yeah. Not MariaDB. Yeah.
Yeah. So one of the when we use the OraPG tool, that's the tool available. So this tool was used for just a DDL migrations. So whatever DDLs we had in Oracle, we just migrated to Postgres, and in that DDL, what we saw that like numeric 38 in a number 38 would migrate in a Postgres as a just a numeric. And in the beginning, we didn't realize that, and later on, we realized that that numeric, just a numeric, had a default precision and scale value attached to it. You don't see there, but in a definition or anywhere. But if you can see that, if you have a like bank ID 3456, it will mention as a 3.4, 5.4. So if you're doing any kind of conversion on that value, you're converting a string, you're putting those numbers in a reports, it would come as a different. And the same behavior, if you define just a number on Oracle will let you, if you say 3, it will insert 3 only. But in Postgres, since it's a default precision and scale, that will insert like 3.0, 4.0, which would mess up, a lot of. So this is just one observation. Whenever I think we should specify in a Postgres explicitly precision and scale. Otherwise, there will be a lot of data mismatch kind of thing. It's not a data mismatch, but it's just a different representation of the data.
In most cases, you should use migrate anyway.
Right, that was my next point. So we had a number of places where if you see like number 30, anything beyond number 30, and we had a lot of arithmetic operations on those numbers. That was really hurting us in a Postgres. It was becoming a really costly operations. So I would suggest, actually, we did converted a lot of fields like that wherever possible to the integer and big int.
And what we did in MariaDB. Do you mind if I tell us what we did in MariaDB? Because that
Sure.
So we have a decimal who works exactly like Oral's number. It's like precision, but it's like an integer, but we can handle 38 digits with efficient disk storage.
Right.
Which number a Postgres unfortunately can.
Yeah. So this is the same point actually I was trying to say. So if you have a number bigger than 20, 30, define in Oracle, better convert into the integer. Looking the storage side also, like big int only takes 8 bytes, integer takes 4 bytes, but in the numeric it's 16 bytes. To store the same exact number here, the numeric takes 16 bytes, and like big int or int would take only 4 bytes. So that's a if you have a small table, number of small columns like numeric, it's okay to ignore. But if you have a very fat table, lot of numeric columns, definitely would like to consider that, because it's a huge space difference. I just want to put that point here. Varchar to char in Oracle, when you define varchar 30 or varchar 20, it indicates in the number of bytes. In Postgres, actually, it's the number of character. So sometime when you are converting Oracle to Postgres, you are probably over allocating your space there. Just to, if your application using a multi-byte character set, if it is not, it would not make any difference. But if your application using a lot of multi-byte character set, then that would make a difference. It's just a point to consider.
But if you only store the number that you actually use, I assume even in Postgres. So if you just move from Oracle to Postgres, the size should be almost identical on disk.
Yes, its size should be almost identical. I would say if 20 byte character, if you are just saying single byte character, it would not make any difference. But if you are storing multi-byte character in Oracle, if you know your application where you know that there are a lot of multi-byte character set coming up, and actually you are saying 20 byte, 20 character in Oracle. In Postgres, you don't need a 20 character. In Postgres, you can shrink it down a little bit. So I just want to put that.
I don't see why that's a problem, because
it's not a problem. It's not a problem.
In Oracle, if it's bytes, what happens if you try to insert the multi-character string, you basically will get an error if you get to.
Yes, you get an error. That's a problem.
Otherwise, you know that they will never be longer than n.
Yeah, but you don't want to get into the situation where it gets an error, isn't it? You want to resolve those issues ahead of time. There is another one, sysdate and systimestamp. This is a very classical, very hard to catch this issue. So sysdate and systimestamp in Oracle, the way it works, within a transaction, they return always a same date and time. If you call multiple times, it will return same date and time. But in a Oracle, on a Postgres, we have similar functions, but there are a lot of functions available, like clock timestamp, statement timestamp, current timestamp, transaction timestamp. Now, lot of people start using a statement timestamp or current timestamp. But if you notice it, basically, so in a same statement, if I put a sleep of 30 seconds, and then I did again same select statement, if you notice it, the clock timestamp coming as a exactly behave like a sysdate or systimestamp. All other values is not a behavior of sysdate and systimestamp. So this we have to care. If you are not doing a lot of inserts into multiple inserts in a same transaction, then it's okay, means it will not affect. But if you are inserting a record and then you are doing something else and inserting another record and you are expecting same timestamp on both the records, there will be a discrepancies and your reports will fail. Everywhere this will be visible, and it will be hard to troubleshoot there where these times going. And specifically if making a call outside the application, then you would think what is happening, either it's not calling it or some issues is going on. On a schema migration, one thing we notice is a case sensitivity. So when we use Ora 2PG tool, most of that tool indicates that basically it converts your objects with the quotation mark and with the capitalize later. So if you import that schema as it is in a Postgres, and let's say here you have created something called employees, and if your code is referring something like select star from employees, in Oracle this is perfectly fine because it's case sensitive. So Oracle will say, okay, this is employees, I am going to return it. In Postgres, everything gets converted into the lowercase. So you will get basically saying no relationship exists. I think this is a very thing, minor mistake, but it will bite you in the end, because depending on which application, how it is using that code, you may get error and it will be hard to troubleshoot later on that.
Right, and just to add, in general, Oracle, your metadata is stored in uppercase. In Postgres, it's all stored in lowercase. So that's a big, big difference.
Another thing about the sysdate and systimestamp was what we found out is your time zone, local time zone on a client side does not affect anything how it is inserted in a database in Oracle. But in Postgres, if you have a data type defined with the local time zone, date timestamp with the local time zone, it will store the client time zone, not the server time zone. So you have to make sure that your client applications, all the client applications are on the same time zone. A couple of other things like partition indexes and global indexes. So Postgres does not have anything global indexes. So there is no integrity between, like you can have a duplicate entry in a different partitions. So you can have a same records in a duplicate different partitions. So there is no uniqueness across the partitions, which Oracle enforce this uniqueness with the global indexes. But since Postgres doesn't have any global indexes, the partition, each partition can have its own indexes, and there is a possibility in application. Sometime, let's say if you are doing something like you are inserting a data, before inserting, if you are checking if it is there, I want to insert it or I want to update it. And if this happening right at the time change, at the day change, so in the previous day you are saying it is, if it is there, okay, it is there, and then the time changes, by the time transaction finishes, it's the next day, you are trying to update, you get an error in your code, because the next day the part that day is not exist, because then it would create a duplicate.
Is the day defined when you run the transaction and not when you commit?
So you begin a transaction and then you commit a transaction between, and that between that time if your day changes.
But the commit, at least in MariaDB, we will store everything according to the start of the transaction time, not the end of the transaction time.
Not necessarily, depending on the isolation level, you can still read it, isn't it? So another key, reverse key indexes. That's I don't miss it much, but if you have an application where if you have a continuous number generation, and if you are doing a lot of inserts, that will generate a last page contention in any applications. Reverse key indexes used to help us in Oracle. We don't miss it, probably because of the way MVCC handles in Postgres. We just removed that reverse key indexes, and our application is still fine without that. Global temporary tables. So some of the reports we used to run as a global temporary tables. Postgres doesn't have any concept of global temporary tables. So we had to change that. So
Can't you just have a public template table that everybody can use? So that is more or less the same.
no, not same, because then you will be able to see the data from other session also. The whole idea of global temporary session is suppose it has to.
Definition, but not the data.
Yes, because the global temporary table, I don't want to share if Sumit inserts the data, he's inserting into the same table I am inserting, but I want to see my data only, not Sumit's data. So,
You can always create a template for yourself.
yeah, but in Oracle, it was so easy to create and easy to use. A lot of reports gets created like that, and then we can't just migrate there.
We're running out.
Yeah, yeah. And again, the toast, I want to go a little bit faster here. Toast, auto commit, and row ID. These are the another. In a toast, basically, you have to make sure that every Postgres table has a toast table, which if it is you are inserting more than 2 KB of data into the row. If it is a fat row, it will create a toast table, equivalent toast table for it. And if you see a lot of toast tables, lot of data in toast tables, since there is a limitation on a toast, the performance will really affect the your select queries. So we would suggest to vertical partition or horizontal partition whenever you see a lot of toast tables in the for any of the tables.
So what's actually stored in those? Is it big blobs or
Big blobs or anything? It could be anything going beyond the 2 kilobytes size. Any fat rows, it will.
okay, 2 kilobytes? Okay, that's horrible.
Yeah. Yeah. And the auto commit transaction management, that's definitely you want to, auto commit on session side. For Oracle, did not had any impact. In Postgres, we had a lot of issues. We had to strategy something like we have to always decide that this is the one we are going to decide. And we removed a lot of transaction control statements from the procedures and functions, because with auto commit it was creating a lot of issues. It's a big subject. I cannot even cover that. I can just talk whole day. And the row ID and identity columns. Basically, row ID in Oracle you cannot mimic in Postgres, so we use identity columns for that. So another.
We have a trick in MariaDB automatically.
Yeah.
If you have a unique key and you use row ID and you only have your one unique key, it automatically map that to row ID.
Yeah, yeah. And the data issue, what we had is there is some applications where we gave a user to input the data from the website. There we used to get a data in a string at the middle of string as a 0 byte, which is a valid character in AL32 UTF-8 character. It's a little bit more characters than the UTF-8 standard. It's valid in Oracle, but it's not valid in Postgres. So we had to correct a lot of data for UTF corrections.
Did you create your own tool or did you use some existing tool for that?
We had a program, a Go program written, which will scan the table and find out all the UTF non-UTF characters, and then report it, and then we have to correct those ones before we migrate it.
But how could you insert the raw?
You can't. Yeah, you can't insert in a Postgres, so we have to scan in Oracle itself.
Okay, you fix it in Oracle.
Oracle, yes, yes. The migration tool, we use Ora to PG just for schema migration. Ora to PG by MigOps, I just want to bring that up because
That's a new one was just released, yeah.
Yeah, new one just released. We use the Oracle Foreign Data Wrapper to answer your earlier question, for initial load only, and Oracle Golden Gate for the live data replications. If you don't have a replication Oracle Golden Gate, there are other options, Kafka related, Kafka Connect related options also there with the WGN, and there are other options also there. So, but we use the Oracle Golden Gate.
Yeah, but assuming you are somebody who doesn't have all the money and want to use open source, what is the best one after Golden Gate?
The WGN basically.
And so Oracle Golden Gate can replicate to Postgres and convert everything.
Right.
Yeah,
It's
I know Golden Gate can also replicate to MySQL and MariaDB, but I don't know of any open source version for MariaDB.
Yeah.
Okay.
This is the one. I think we have 9 minutes left. Okay. This is our Oracle.
What I would say is, if you want to go to the diagram quickly and then maybe
Yeah.
cover that rather than because we are short on time.
Yep. Sorry. So on a data migration, this is the way we followed how we did the data migration. We had a Oracle servers. We set up a migration server which is near to the GCP GCP zone, basically GCP region. So the migration, the role of the migration is to stage the trail files and the.
What's a trail file?
So for Golden Gate, every Golden Gate application basically all the change data capture basically will generates a trail file, and that trail files are locally stored. We don't want to store all the trail file while this migration is going on, because we know that this is going to take a time and we don't have that much time to store those trail files here.
So it's nothing but just like in your Postgres, you have all logs, on
Yeah.
MariaDB, I think
Any
binary log, it's
yeah.
similar to that. Yep.
Yeah, similar to journaling, but it has a lot more information to recreate that transactions which Golden Gate understands.
So Golden Gate is using those for replication.
Sorry?
So does Golden Gate use the trail files for replication?
Yes, Golden Gate uses a trail file for replications. Yeah.
So just high level, right? I mean, Golden Gate is a big subject. We can cover we can talk 2 days for Golden Gate, and we're running out of time. So initial instantiation was done by foreign data wrapper, which is everyone I think in the Postgres community knows about it. And Golden Gate was just to capture the deltas. So it's just nothing but another CDC tool. Like Debezium is another one, like Vinay covered earlier.
But foreign data wrapper, I don't actually know anything about it, but I assume that you come from Postgres, ask Oracle, give me this data.
Yeah. So basically, the foreign data wrapper, it's a DB link in Oracle. You can say that. So basically, you configure on a Postgres server, and you are asking here directly to the Oracle server, saying that.
Is it through ODBC or?
Sorry.
ODBC. Yeah.
It's ODBC connection. Yeah. But when you use Oracle foreign data wrapper, there are certain things you have to keep in mind. If you change anything in a Oracle side, you have to refresh those definitions in a foreign data wrapper. That's one thing. Joins are horrible. It's performance hog, really bad performance with the joins. So those needs to be converted into the subqueries actually.
And I think one of the other points, which probably is in one next slide, but just to wrap up from this topic, was the partitioning, right?
Yes.
Yeah.
So in a foreign data wrapper, that's about the Golden Gate.
Yeah.
So this is the basic process we went through it. Like Golden Gate, I think.
Yeah, we can skip over it, I think.
Yeah. So we just set up the Golden Gate. What that slide itself basically talks about all these things. We set up the Golden Gate here. There is a migration server here where we install Oracle Golden Gate for the Postgres actually, which talks to the Postgres. Basically, it's a Postgres replicate which talks to the Postgres server. And
I do have one question, I haven't read one.
What is?
So when you had used the Oracle the foreign key. Basically, when you copy the data from Oracle for a table to Postgres, how do you know at which point you should start?
Yeah.
That's what.
That's what this is.
I knew where you were going.
I knew. So since you did, so you know the pain points actually. So so in a Oracle in a foreign data wrapper, we created in Oracle side one table, temporary table, where it says what is my current SCN, you know, in Oracle when I'm beginning a transaction, what will be my current SCN. So
What's an SCN?
it's a system change number. So like any journaling would have that number, some kind of number.
We call it LSN.
Yeah, every DB will say differently. But the point is, we are setting up a transaction in a repeatable read. So it's kind of after that, when you run this statement, the insert into some this table. So when I'm beginning a transaction, it's taking a snapshot basically.
Yeah.
So
But how do you know that if you have two tables and you have started their snapshots at different times, how do you?
it is possible. Yes, it is possible. That's why a whole every table in Oracle we divided into the parent-child, basically in parent-child relationship. So we just migrate the parent first, then the child, then the child, then the child. So whole.
But if that's from different times, then when you start replication, they will have a replication stream will always start from one place.
Right. So it doesn't matter, isn't it? Because there are some tables which is taking a lot more updates. Because when we start this process, that's the time for SCN. That table needs to get updated.
So each
And
table will have a different SCN.
yeah, each table would.
How do you can Golden Gate know that this table has SNN?
You let it know.
That let it know. You let it when Golden Gate you start. You let Golden Gate know that from this SCN I want to start.
Yeah, but can you say that for this table I need to start for this?
Yes.
Yes.
Okay.
Yeah. Golden Gate is very flexible in that. So that's where the Golden Gate configuration is very heavy. That's where we decide the whole. If you have 1,000 tables, we divided those tables into 200. Those tables have a different replicate, so that every SCN, those tables follow the same SCN, and we can configure the replicate for those tables only. So that whole table.
This is probably a really stupid question. That's such an easy answer. So you have Oracle here. So why don't you just take a snapshot of Oracle here, take it down, copy everything?
It's not possible.
Downtime was not an
Downtime is a zero.
We had a 0 downtime requirement. We
So-
cannot take the business down.
Yeah.
No. You listen this to me.
Okay.
You have Oracle here. You are running it. Then you take a snapshot here, and then you take down this. Then you copy everything here to Postgres,
No, but
and then you start replication from this snapshot where everything has the same.
That's a too big database
If you're-
to
if
make
you-
one snapshot. It's
How-
like 20-30 terabytes of the
That's
data.
one hard disk nowadays.
It's
still, when you have to manage with those things, yeah, it can be too much.
Yeah.
And then you have to worry about all the other dependencies, dependent
Yeah.
objects, parent-child relationship. I mean,
No, you
a
don't
lot
need
of
to
things.
You don't need to if you get a snapshot here. You have
Right.
everything here.
Yeah, but
Small
it's-
DB possible, I think. I don't think it's
Yeah.
it's a good
Big-
idea for a large.
and-
Yeah.
And plus, it will be a nightmare to get that sync after that, because then
So
you need that big a Golden Gate configuration also. Golden Gate also, like we divide a lot of tables into the replicates into the lot of
In
tables.
this case, you don't need to do that.
No.
Because you have snapshot.
Yeah,
yeah.
we can
We'll
go
discuss, yeah.
over Golden Gate stuff
Yeah.
later on, but yeah.
Yeah, I think this. Yeah, go ahead.
Yeah. This is some tips and tricks. And when you go on Postgres, I think always never forget about the auto vacuum. Never turn it off. Always keep it on. There are some parameters. Auto vacuum is a very huge subject. We can talk days for that, but there is some parameters which controls.
I don't have any questions. We don't have vacuum. We don't need
Yeah. So,
Maybe you have a question.
so I'm just going to go finish quickly. So basically, there are some parameter controls, how many percentage I add to the table, and there are some parameters controls on a number of tables I want to vacuum that. So auto vacuum basically prevents the wraparound issue. Now in the new Postgres, that's not an issue anymore, but auto vacuum has not should not be turned off anytime.
Yep. Let's go to the next slide.
And there are some options for full vacuum. When it does full vacuum, it does lock the table. So you definitely want to use a different tool also. There is a PG repack also there. So full vacuum, what it does, auto vacuum doesn't reclaim the space, even though it's removing the dead tuples. It doesn't reclaim the space. Full vacuum does it, but on the other end, it locks the table. It's basically making a different copy of the same table and then cleans up the table. PG repack is the similar as full vacuum, but with the concurrent full vacuum basically. You definitely want to run a vacuum analyze after even running the bulk insert. This is the same as the Oracle statistics you manage. So that is the one. Some of the performance related parameter, work mem, shared buffers, wall buffers, and huge pages, that needs to be looked into it. Default statistic target. So when Oracle Postgres collects the statistics, it has a limitation. So how much data to scan, it has a histogram, it has values for how many nulls. It's similar way any stats data collected on any table, but sometime for very large table you may want to increase that default statistic collection for that specific tables. Plan cache mode, that is basically so this is something related to
So Vinay, I think let's just skip over those. We have a couple of other slides.
Okay.
So these are just the parameters we played around on the
Yeah.
performance side. So just to keep that in mind. Yeah.
Yep.
So just go to the next slide. Yeah.
Okay, Sumit, you want to cover that?
Okay. Sure. I know we are running out of time here. So this is nothing but, I mean, just a quick comparison of how, if you're used to Oracle, just a comparison on in Oracle AWR reports, which gives you a snapshot of your instance, what's running in your, or what queries are running slow, or how your database instance parameters are doing. In Postgres, you have similar PG Stat Monitor. I think one of the engineers from Percona wrote that, if I'm not wrong, and PG Badger. Then monitoring side, OEM, which is Oracle Enterprise Manager, I'm sure you're aware of. Percona, we have Postgres, we have PMM from Percona. HA Data Guard, like we covered all along, Postgres Standby Database, Petroni, that's what we are using. Golden Gate. Golden Gate is a big product which has a lot of features. Postgres logical replication is, it's not there yet. It's getting there, I guess, but it's still available for basic stuff. Encryption, we are struggling with this right now. Encryption TD on Oracle is there. Postgres, you don't have any schema level encryption. There is some limited functionality you could do with PG crypto. Otherwise, you have to rely on your storage level encryption. But we have some customers who ask for schema level encryption, and we're kind of figuring out how that can be resolved. Now, backup.
One transfer in MariaDB and test it, and then you have it.
On the backup side, RMAN in Oracle, PG Barman, Barman and PG Backrest, and similarly export and audit. Yeah. All right. Okay, this slide is just not related to the topic, just to tell a little bit. So within Broadcom software, we've invested a bit on Kubernetes side. We are running several, I don't know, maybe 100 or so Kubernetes clusters, GKE and Google Cloud, and using operators big time. So these are the 3 Percona operators we are using. There are several other operators we are using.
Which are the 3? You mean MongoDB?
MongoDB, MySQL, and Postgres, PXC basically. And just a few points there. So this allows to shift left. Developers can do their own thing. They can deploy a database within minutes. We do the Helm template. So we take Percona's operators, we templatize it via Helm, integrate with our CD pipeline, and then developers are on their own after that. And we have some production instances as well running. So yeah, it gives self-service deployment with a single click, like I mentioned. You can do basic operations, scale up, scale down, HAs out of the box. And self-healing, this is something new which Percona started doing with later versions of the operator, more stability. It's fixing on its own. If there's a pod restart or whatever happens, it self-heals and comes back. So that's a cool, and backups, obviously. Yep, with that, I think we are over time. We made it a little bit interactive, I guess. So, yeah.